Hello. We're going to spend the next few minutes talking about adding and subtracting with significant figures values. And to do this, I just must understand that the addition and subtraction remains the same. What changes is the answer. And the answer must be given with the number of the fewest decimal points. That is the numbers with the data to the right of the decimal point, the fewest ones. Let's look at two samples. If I have 52.52, 14.0, and 29.42. Out of these three numbers, the one with the fewest digits to the right of the decimal is the 14.0. I only have one. So my answer will have only one digit to the right of the decimal point. When I add these three numbers, the answer is 95.94. And I only want one. And if I cut off the 4 is not big enough to round up the 9 to the next number. So my answer becomes 95.9 centimeters. Again, keeping the value to the right of the decimal point, which is only one. One here, one there. I want to go with the fewest number of digits to the right of the decimal point. In this case, it's only one I have here. Sample 2, subtraction. 1,982.9 minus 875. I have no decimals on this number, so my answer will have no decimal points. And I end up with 1,107.9. But I don't need that 0.9 because here I have nothing. Therefore, my answer will be nothing to the right of the decimal point. This will become, therefore, 1108 or 1,108 because the 9 was big enough to round the 7 to an 8. Let's do multiplication division. When I divide significant figure values, the answer must be given to the value of the least amount of the total significant figures. Okay, because sometimes when you divide, you get this large sum of numbers to the right of the decimal point. We want to avoid that by creating some rules. Example, 21 divided by 2.27, 21 times 2.27. I have 1, 2, and I have 1, 2, 3. So my response will be with only two digits, only two significant figures. Therefore, when I multiply those two numbers, I get 47.67. But I want only two significant figures because I only have two, and I want the least amount. Therefore, this becomes 48 because the 6 is big enough to round up the 7 to an 8. The answer is 48, in this case, meters squared, because I have two m's and each m has a power of 1. Division example. 6.80 divided by 3.4. I have 1, 2, and I have 1, 2, 3. Again, my answer will have two digits only. When I divide these two numbers, my answer is 2. But I need to add the unit values. In this case, it's meters over seconds. I cannot cancel that. So 6.80 divided by 3.4 gives me exactly 2. But since I want two significant figures, the answer becomes 2.0. And this gives the value of two significant figures. It doesn't change the value of the answer. It's still 2. But I must make it to the proper amount of significant figures. In this case, is 2. I hope this helps you out.